And good day. So my name is Muhammad Din, and I'm going to explain to you about the um login users here. So the part 3, which is the completed secure system. So we are doing UTM secure event management secure event registration system. So the first one, I'm going to explain about what the security features have been done inside here. So the first one is input validation. Of course, this one have input validation where to see whether this is like legitimate input by the users. Let's say if we input something not email, okay? And then with the password, okay, so you can see here, it says like this is not an email address. So this one is like this one shows that it will filter out what is the input by the users. So as you can see here inside the code, here, as you can see on the login page, a register page, line 7, if I'm not mistaken. Yeah, this one is empty and email. So this one also required an invalid email format. As you can see here, this one it will filter out the invalid email format. Okay. So back to the system. So let's say we try to do another one, which is multiple attempt. Okay, and then the password, let's say, okay, login, cannot. Okay, we do another one. Cannot. Okay, another one. Cannot. So there's too many failed attempt and try again in 5 minutes. So this explain that there's no brute force on these applications. So this one will do brute force failed attempt. So as you can register here, also this one like except like non email, register cannot and fill the blank. Let's say like this. And this one is not an email. Okay. This is a normal authentication here. So if we try to enter again back, it says we need to wait for until 5 minutes. So this one is of course it will shows that no failed attempt is allowed in this system. Okay, now we are inside the system. So as you can see here, these are the system when we have logged into with the correct credentials. So as you can see here, we have events, my registration here, and so on. So as you can see here, we can add event here. So let's say we want to register this event. Okay, so after we register, okay, it will go to my register, right? Cybersecurity workshop, first kita, and also, and it won't allow you to do another registration here. As you can see here, it says already registered. Only one time registration only. So the code here, as you can see, where's the register event? So here you can see here already registered server side check. So this one will check you if you already registered. So it will don't have another redundant registration. So this is for event registration. So for the next one is let's say if they try to do to go for admin page. Okay, let's say they want to change here admin page. Okay, now we are in the student page. So we go admin, let's say dashboard. Okay, admin and dashboard.php. So you can see here, it just go straight away to student dashboard back because it will not let you to go for admin dashboard. Because of what? Because of this code. As you can see here, this code, it will check you either you admin or you a student. So even if you try to go for admin dashboard, it will cannot go. Okay, that is for role-based access control. And for just now for event is the transaction integrity. For and then secure management where this app is actually have session where HTTP only, which is same site string, and secure if you serve over as HTTPS. Okay, so it have like the session ID, so it will log out if after 15 minutes of timeout or 1 hour of absolute timeout. And you can see inside the config session.php here. Sorry, session. Yeah, this one will do the timeout for session, which is to have the timeout. Okay, and I think that's all for the system. Thank you.
I'm Nursyuhada, and in this segment, I will explain the key security features implemented in UTM Secure Event Registration System. First, password hashing. User password are never stored as plain text. We use a secure one-way hashing function to convert every password into an irreversible hash before it is saved. As you can see here, every password in the database starts with the same prefix. Confirm a strong hashing algorithm was used. During login, a separate checking function compares the entered password against this hash without ever exposing the real password. So even if database were leaked, attackers still cannot recover anyone's actual password. Next, SQL injection prevention. All our database queries use prepared statement with bound parameter instead of directly insert user input into SQL string. This means user input is always treated as data, never as executable code. We tested this during suit with payloads like O1 equal to 1 and a targeted attempt using a real email address. Both attempts were rejected with the same generic invalid email or password message. No authentication bypass occurred. Request forgery protection. Every form that changes data like login or event registration include a unique token generated per session. The server checks this token using a secure, constant time comparison before process the request. When we intercept a request in verb and strip out the token, the server immediately rejects with invalid CSRF token. Confirm forged request from outside, the application cannot go through. Next is output sanitization. Any user supply content that get displayed later, like an event title or a username, is passed through an encoding function before rendering. When we tested this by submitting a script tag as an event title, it was stored but displayed back as harmless plain text instead of execute as a script. No pop-up, no code execution. Fifth, role-based access control. The system defines two roles, administrator and student, and every protected page check the user role on the server before granting access. We tested this by logging as a student and manually changing the URL to the admin dashboard. The system detected that the account only has student privilege and redirected us straight back to the student dashboard, confirming access control is enforced on the server, not just hidden in the interface. 6. Secure session management. After a successful login, the application issue a completely new session identifier and invalidate the old one, which prevents fixed session attacks. We also enforce an automatic session timeout So an inactive session gets destroyed and the user has to log in again. 7. Brute force protection. Failed login attempts are tracked per session, and after 5 consecutive failures, the account is temporarily locked. When we repeatedly submitted wrong credentials through burp repeater, the server responded with too many failed attempts. Please try again in 5 minutes. And that countdown keeps decreasing on later attempts, confirming it is a real time-based logout, not just a one-time message. Lastly, secure error handling. Whether a login fails because of a wrong email or a wrong password, the application always shows the same generic message: invalid email or password. No database detail, file path, or technical error are ever shown to the user, which prevents attackers from using error message to figure out how the system works. Full technical errors are still logged on the server side, so developers can debug issues without expose anything to the public.
Warahmatullahi wabarakatuh. My name is Farah Nisha bin Abdul Latif. Now I want to present the action flow diagram for our system. Okay, this action flow diagram illustrates the overall workflow of the secure event registration system, which is for student and admin, starting from the user authentication until event management and registration. It also highlights the security mechanism integrate throughout the application, throughout the website application. Okay, first for the login or registration, at first, the process begins when the user accesses the system. If the user already has an account, they proceed to the login page by entering their email and password. Otherwise, the user register by providing their name, email address, and password. Okay, then during the registration, several server-side validation checks are performed. And the system first will check whether any required fields are empty, whether the email format is valid or already exists, whether the password satisfy the required complexity policy. If all validation check pass, then the password is securely hashed using the PHP password hash function by using the bcrypt algorithm. So it will bcrypt before being stored in the database. And CSRF token also will be generated to protect the subsequent requests from the cross-site request forgery attack. Then after the registration, or if the user already has the account, and during the login, the submitted credential undergo input validation and CSRF token verification before the database query is executed using PDO, prepared statement. Then after retrieving the user record in the database, the password is verified using the PHP password verify function. And if authentication failed, an error message is displayed. And the system also track fail login attempt from this one. And if the maximum number of attempts is exceed, the account is temporarily locked for 5 minutes to mitigate the brute force attack. Okay, then after successful authentication, the application regenerate the session identifier using the session regenerate ID to prevent the fixed session attack. And the user's role is then checked to determine whether the user is an administrator or user or student. Okay, for the administrator workflow, administrators are redirected to the admin dashboard where they can manage events by adding, edit, or deleting the event and viewing the event registration. this one. Then these functions are only accessible to the users with the administrator privilege through the role-based access control, which is RBAC. Then for the student workflow, students are redirected to the student dashboard where they can browse the available events and register for the events, which is this one is for register, and this one is to view their own registration. And students are restricted from the accessing the administrator function to ensure the proper authorization is enforced. So, overall, the action flow demonstrate how security mechanism such as input validation, SQL injection prevention throughout the prepared statement, CSRF protection, password hashing, brute force protection, secure session management, and the RBAC are integrated throughout the application workflow to provide the secure authentication and authorization. In addition, in the system also have the session timeout where the system um, will be automatically log out from the system after either time for the user in about 15 minutes. So that's all from us. Thank you.
So continue to the last part, which is part 3, final integrated secure applications. For part 3, we developed the final integrated secure application known as UTM Secure Event Registration Systems or users. This system combines authentication, authorization, transactions processing, and session management into a secure web application environment. So the application integrates multiple security mechanisms to protect user credentials, restrict unauthorized access, maintain data integrity, and prevent common web application attacks. Next, I will discuss the security testing and evaluation conducted to verify the effectiveness of this security control. So for SQL injection testing, figure 1 to figure 4.4 show SQL injection payloads being submitted through the login form using Burp Suite. The application rejects both attempt and displayed the message invalid email or password. This demonstrates that PDO prepared statements successfully prevent SQL injection attacks. And then for the CSRF attacks, figure 4.5 shows a legitimate event registration request containing a valid CSRF token, while in figure 4.6, the token was removed before the request was resent. And last, for the figure 4.7, shows that application rejected the request and displayed an invalid CSRF token message. So this confirms that CSRF protection is functioning correctly. For brute force protection, figure 4.8 shows repeated login attempts using incorrect credentials. And after several failed attempts, figure 4.9 shows that the account was temporarily locked. And then in the figure 4.10, further confirm that the lock remained active during the waiting periods. So this demonstrates that brute force protection mechanisms successfully limit repeated login attempts. And then for role-based access control testing, in figure 4.11 shows a student user logged into the system, while in the figure 4.12, the student attempts to access the administrator dashboard by modifying the URL. So in the figure 4.13 and 4.14, show the application detected the unauthorized request and redirect the user back to the student dashboard. So this confirms the RBAC is properly enforced. For parameter manipulation testing, in figure 4.15, shows a legitimate event registration request. And then in the figure 4.16, shows the event ID being modified to an invalid value before submission. So here in figure 4.17 shows that the application rejected the request and displayed an error message. This demonstrates that server-side validation successfully prevents parameter manipulation attacks. And then moving on to cross-site scripting technique. In figure 4.18 shows an XSS payload being submitted into the application, and then in the figure 4.19, 20, and then 21 shows that the payload was displayed as plain text instead of being executed. So no JavaScript pop appeared. This confirmed that our intelligence using HTML special class successfully prevents for XSS attacks. And then for input validation testing, figure 4.23 until 4.28 here shows tests involving an empty field, invalid email format, and weak password, where in all cases the application rejected the invalid inputs and displayed appropriate validation message. This confirmed that server-side validation is correctly enforced. And then for session fixation testing, in the figure 4.29 and then 4.50, compare the session identifier before and after login. So the session ID changed after successfully authentication, demonstrating that session generation is implemented and protecting the application from session phishing attack. While for password storage verification, here in figure 431 and 432 shows that passwords are stored as private hashes rather than plain text. From here, it ensures that user credentials remain protected even if the database is compromised. Finally, for the session timeout verification, figure 0.33 shows that the application automatically log out an inactive user and required re-authentications. This reduces the risk of unauthorized access from unattended sessions. So, overall, all the security tests produced the expected results. The implemented controls successfully mitigate common web application threats, including SQL injections, cross-site scripting, CSRF attacks, cross attacks, unaddressed access, parameters manipulation, session phishing, and session hijacking. So in conclusion, the UTM secure event registration system successfully integrates secure programming practices, cross authentication, authorization, transaction process, and session management. The implemented security mechanism effectively protect user information, maintain data integrity, and then provide a secure platform for event registration and management. Thank you.